This is a lesson video for 7-3 Day 2, Integration by Parts. We're going to work on choosing the U and the DV today. So as you go through, there's a warm-up on the screen. Stop the video, do both of those, look back at your notes from yesterday, and then come back when you're done. If you're back, then you're back to check. So these are the things we worked on yesterday. Number 1 is just the formula, and number 2 then is picking. We picked the U and the DV for you, and then completing that process and simplifying it. So again, pause the video where you need to. Today, general guidelines for integration by parts, and remember these are guidelines, these are not 100% absolutes, so in some instances we would go against these, but not in very many instances. It doesn't always work or apply for a given integral, so we want to keep that in mind. And then in general, we want to talk about choosing a U so that its derivative will be simpler than it was. So for instance, x squared's derivative is 2x, that's considered simpler, it's a lower power. E's typically are one of the last things you would pick for your U because its derivative typically isn't simpler than it started. Then you want to choose your DV to be the more complicated part in general so that it'll be easily integrated. We'll talk more specifics on that today, but keep in mind these are guidelines, these are not absolutes. So if you come back and say, but I thought you said we always, we're going to say, no, not always. So let's do a couple, and let's pick the U's and the DV's. So in this one, the integrand is 2x e to the 4x. And in general, we want to pick our U so that its derivative will be simpler. So we have to break everything in here into being part of the U or part of the DV. I think that 2x, that expression, will be an easy U to take the derivative of, and it will be simpler than it started because its derivative will be 2 and then dx. And the dv, if I make that e to the 4x and include the dx, I can integrate e to the 4x. I may need to go over on the side and do a little bit of u substitution, but again, I picked my u to be so that my du will be simpler, and my dv is something I could integrate. So pause the video, try to finish this one up, and then come back when you're ready. So on this one in purple, I showed you how I did my substitution so that you could see how I got my v. And then I showed you how I used the rest of integration by parts in order to get to that final integral. Again, plus a constant because you're doing the general antiderivative here, and therefore there's a whole family of functions whose derivative would be that original 2x e to the 4x. So there is a little way to remember what you might use to pick the U. It doesn't mean that this works 100% of the time. It means it works in general. So in general, every once in a while, if something isn't working, we may have to choose differently. But in general, to pick your U, you'd pick logarithmic functions first, ln's, because their derivative is simpler than they are, inverse trig functions, then algebraic functions, and algebraic would include your polynomials, your rationals. T is trig functions, and then finally E is exponential functions. And again, this is in general, not 100% of the time, but this is liate is the expression they sometimes use. Again, pause the video and get these in. So let's try that in picking our expressions here. So if I've got my integrand of x ln of 2x dx, liate says that that natural log part would be what I'd want to pick for my u. So natural log of 2x, I'm going to take as my u expression, and then my dv is going to be the x expression, again, along with that differential of dx. So complete these, and then come back, again, pause video, come back when you think you have this one. If you're back, then you're checking to see that first of all you took care of your du and your v correctly, and then that you went ahead and found the general antiderivative for that expression. Reminding yourself that how could you check? You would take the derivative of this entire expression and see that it matches your original integrand. All right, last example. You want to use liate and see what we can decide on here. So in liate, again, logs, inverse trig, algebraic, trig, exponential. Remember, exponential means that x is up in the exponent. So looking through here, Liate, logs. I have a log expression, so my u can be one of two things. It could be ln of x squared, or you can rewrite that as twice the natural log of x. My dv then needs to be the rest of the expression and carry it out from here. So pause video, try this one out, and when you come back, check it. So a little on the quick side. Hopefully you've been pausing the video so that you're actually getting out of this what you need to. Your tasks in the book are section 7-3, 1-4, and 9-10. Make sure you're showing all your steps.